Hi, Assalamualaikum warahmatullahi wabarakatuh. Today, our group will present the result of our solid mechanic experimental lab, namely shear force of a beam. Our main objective today is to see if the theory we learn in the class is the same as what happened practically.
We are from Group 3 and I would like to introduce to my team members Haikal, Farhi, Matthias, Kir, and also me myself, Manu.
Before we look at the data, let's first understand what shear force is. Simply put, it is a force act parallel to the cross-sectional surface, causing adjacent part of the body to slide past each other. The most classic example is like a deck of cards. When we put the bottom and top in opposite direction, it slides. That shows in this experiment, our beam has a special cut part connected to a lot cell to measure this internal force directly. To verify this experiment, we use two theoretical approach. First, the apparatus specific formula SC equal W dot A divide L, where A is a distance from the load to support. Second, we use the principle of static equilibrium, which is that the sum of the moment and the sum of vertical force must be zero to find the reaction force at RA and RB.
Assalamualaikum warahmatullahi wabarakatuh. My name is Shear and right now I'm going to explain about the data that we have obtained from the experiment. In this experiment, we have run two tests, which is test A, shear force variation for increasing loads, and test B, shear force variation for various loading conditions. So in the test A of shear force variation with increasing point load, we have obtained several data. With the data, we have achieved this graph. As you can see, the data shows a linear line. It shows a direct proportional relationship between the load you put on the beam and the shear stress on the cuts, which means when the load is double, the shear force also will be double. On the test B, we have gained the experimental shear force data. There are three setups that we do to get the data. Based on the figure 8.6, we have negative 1.2 Newton. Meanwhile, on the figure 8.7, we got 3.3 Newton, and the figure 8.8, we got 1.9 Newton. In order to get theoretical shear force, we must use the formula that have been mentioned by Muhammad Kakal before this, which is the SC equal to W times A over L. With that, we can get the theoretical shear force for the figure 8.6, 1.25, and figure 8.7, 0.63, and lastly, figure 8.8, we get negative 0.01.
So, as the discussion part, we have discussed in our group that the graph shows a linear relationships between the load and the shear force, meaning that the shear force increases directly and proportionally with the applied load. The experimental results closely match the theoretical values, which mean the graphs almost overlap, showing only a small errors exist. This confirms that the equation used are accurately predicts the behavior of the beam.
And for the application in real life, we can see that the pitch the beams or rafter are at an angle gravity still pulls straight down, but our beam is slanted. This means the gravity load splits into two jobs. Part of the weight pushes along the beam trying to crush it, that's axial force. The other part pushes perpendicular to the beam, that's our shear force. Also for cantilever beam, this is a beam that is supported at only one end, unlike a bridge where the weight is shared between two piers. A balcony has to send all its load back to a single wall. As you walk to the edge of the balcony, the shear force increases as you move back toward the wall. At the very point where the balcony meets the building, the shear force of it is at its maximum. If a balcony were to fail in shear, it wouldn't just bend, it would snap or slide straight at the face of the wall. This is why we reinforce that specific connection so heavily.
Assalamualaikum, my name is Mahfai Chris. My matrix number is CD250031. Alright, so to wrap everything up, here's the big picture. First, we managed to prove that there is a clear linear relationship in the data. The trend wasn't just random noise, it's actually followed the theory the way it was supposed to. Second, the theory and the experiment sync up nicely. That means our assumptions were solid, our method was on point, and the results stayed consistent throughout the testing process. And lastly, the main objective of this experiment was successfully achieved. We set out with a target, we followed through with the procedure, and the outcome matched exactly what we aimed for. So overall, the experiment works, the data speak for itself, and the results support the theoretical model. Simple, clean, and to the point. So that's all from our conclusion. Thanks.
That brings us to the end of our presentation. We would now like to open the floor for any question regarding our experiment or finding. Thank you.